Hello, ladies, and welcome to your next component, water quality. I'm sorry the first one didn't work, so I troubleshooted and I fixed my mic, and now we're back. All right, so let's fix this all up, and I'll upload it, and then you guys can still get it through today. Otherwise, we're going to run out of time, so let's go for it. All right, so now we're going to deal with water quality specifically. We finished with water availability. Water quality is not a huge component of your June exam, but it is definitely there. And I'm just going to point out the important bits of each slide, just so that you guys aren't writing down absolutely everything. So don't write down everything unless I say it's important and you need to actually write it down. Let's go. We're going to be looking at the use of water. We're going to be looking at effective mining, thermal pollution, alien plants, which we've covered a lot already. Well, not a lot, but enough. And we're going to look at water purification and recycling. Water purification and recycling is probably like the second most important after uses of water. And the effective mining we've already done in the activity I gave you yesterday. So it's not going to be too crazy. All right. So, water quality is the term used to describe the physical, chemical, microbiological, and aesthetic properties of water. Okay, there are 4 of them and you need to know them. You don't have to know the description of each one, you just need to know the 4 different kinds. So there's physical water quality, and this refers to the pH and turbidity, so how cloudy the water is. Chemical quality, and it's just for the type and concentration of dissolved substances such as salts and gases. I'm not too fazed about gases, I'm more worried about salts. Microbiological water quality, so this is the microscopic organisms like bacteria and viruses in the water, which is also pretty interesting. And then the aesthetic, which is what a lot of us worry about. We don't worry about physical, chemical, microbiological. We're worried about what the water looks like. Okay, so does it, what is its taste, what is its odor, and what is its appearance? Okay, does it look nice? All right, so now we're going to start uses of water. So we're going to start with domestic, then we'll go into industrial, and finally we'll finish with agricultural. So I hope that you know what you use your water for in your house. I'm just more fazed about the fact that you know the top 3 uses of water, maybe even the top 4, because it's quite important. So we've got the toilet, which we flush all the time, and we should be, following to a large extent the whole, if it's yellow, let it mellow, if it's brown, flush it down. Washing of clothing, that takes a lot of water. It really takes a substantial amount, and if we can recycle their water, that would be very useful, like we spoke about in the previous lesson with grey water. Then finally we have the shower. Showers and bathing, you can see, is a lot less. It was actually found eventually when we started changing the different kinds of shower heads that shower reduced a substantial amount. It's just because more people shower than bath that number's higher. And finally, leaks, which we've mentioned a couple of times. Alrighty, so then we have our domestic use. The thing I really want to point out over here is detergents. Okay, it's highlighted nice over there. Detergents are the definition for detergents is anything that you use to clean your dishes with, or your pots and your pans and stuff like that. So the detergents really, they're not biodegradable. They don't break down properly. They do, but it takes them an extremely long time to actually do that. And that's because a lot of the stuff is completely synthetic. And that's because we've manufactured it in such a way that it can clean properly, but we're not really worried about once it goes down the drain. The other problem is, remember when I had disgusting in my class, is that, let's say there was some really dangerous bacteria laying in over there, and we washed that down the drain, and boom, we then had pathogenic bacteria going into the water system, and without a proper water system, not a water system, purification system, we're not going to get rid of a lot of that bacteria. So we're going to have to add chemicals, but we'll talk about which ones we can and cannot. So then we're going to talk about human feces, and remember, a lot of people don't have access to proper toilets, so they're going to put in a bucket or something like that, or a makeshift toilet, and they're going to throw it in the river. And some of the biggest diseases that we're going to get from there are cholera, typhoid, hepatitis, and dysentery. Okay, I'm most worried about cholera and dysentery for grade 11. So cholera, it found in the poop, and it can cause diarrhea as well as dysentery. This is something that causes water to move via osmosis based on how the actual bacterium works inside of your gut. And that can also cause a type of diarrhea and can actually lead to death if not sorted out properly. All right, so now we're going to look at industrial. So, industrial use of water, used as a solvent in food. Remember that water is a universal solvent. It's used for alcohol production. A lot of your alcohols, they might not necessarily dilute in water, but they are used as a basis to get all the other ingredients inside. And finally, to cool down machinery to a large extent. You know those huge silos that you see sort of going to the north, or at any power station. A lot of the time, all that excess heat is moved up the side of those and water is thrown down, and that creates a lot of steam. All right. And it's actually a problem because steam itself can actually create, or is made out of water, which is a greenhouse gas, which is actually a big problem in the greater scheme of. All right, so then water used for industrial purposes may contain the following pollutants: heavy metals, paint, solvents, glues, varnish, oils, and salts. I'm way more interested in heavy metals, oils, and salts. I'm not too phased about paint, solvents, and glue and varnishes, but I will mention it a little bit later when it comes to how humans are affected by that. And you can quite clearly see that their water is completely the incorrect color. Like, it should not have a red tinge, and that could be because of a range of any one of those on the left-hand side over there. All right, I'm going to focus on heavy metals for a bit. So heavy metals such as lead and mercury cause disease and may even result in death in humans. So what are heavy metals? The two main dangerous ones is mercury as well as lead. Okay, so mercury and lead really cause a lot of damage to us, and we find mercury in thermometers. It's that metal that is a liquid at room temperature, and if you had to play with it in your hands, you'd think, oh, it's not going to absorb, but quite clearly it is actually quite volatile, which means it likes to break apart, and you're going to find a lot of those mercury particles actually being breathed in while you're playing with it, as well as being absorbed into the skin. Unfortunately, it is one of those things can get into your skin and you will die. Like, it's as simple as that. Mercury, the body doesn't know what to do with it, so it starts to store it in different places because it can't break it down. And this is with actually any chemical that our body can't break down. So it sends it to the liver, and the liver has no idea what to do with it. So it says, okay, fine, we're just going to store it in our fat deposits. So it sends it to a whole bunch of different places, and it just sits in there doing its damage. And this can cause cancers, it can cause respiratory diseases. Oh, there's a whole bunch of stuff. But let's talk about how, without drinking it out of your water, where you would get it from. So this is called bioaccumulation. So you can see that there's a coal plant over there and there's a volcano that is releasing a whole lot of mercury into the atmosphere. Okay, so it's a type of gas that's being released. That eventually is going to end up in water. Then the krill, which are bottom feeders, sort of like little, what do you call those lovely little things? Prawns, but like super baby prawns. They scrape the bottom of the ocean and they eat up a lot of this mercury. Then the salmon and oysters and pollock, they're going to eat all of that krill. And remember, the krill's been storing all of this mercury in their system. Once that happens, then the salmon's going to, or the oysters and the pollock, they're going to start holding onto that mercury. But because they're eating so much and is being stored so much, is going to start building up in their system. Now, before that salmon, pollock, or oyster die, the trout or tuna, they're going to eat the smaller fish. So you can see that it's this whole idea of, and the whole idea of, the predators are accumulating a lot of the stuff. And remember that when you did food chains in grade 10 as well as in grade 8, something that is higher up on the food chain needs to eat a lot of what is below it so that it can get the correct amount of energy. So the trout and tuna are actually eating a lot of salmon, oyster, and pollock, and that is causing a large amount of mercury in their system. Even though they eat only a few times a week, it's still a lot that is being built up. And finally, we have our sharks, pikes, albacores, and halibut. We don't really eat shark, pike, and albacore, but we do eat halibut, maybe not in South Africa as much, but it is eaten, and that is where the mercury levels are the highest, okay? We also eat a lot of tuna, and canned tuna could potentially hold a lot of mercury because remember, we don't have tuna farms. We fish for tuna out on the open seas. So the probability of them having a lot of mercury is very, very scary and high. Okay, so heavy metals are passed on through the food chains, accumulating in higher order carnivores. That is a definition I'd like you to know. Then the ingestion of heavy metals by humans and other animals lead to serious health issues and even death. Okay, solidly death. All right. I'm not too phased about here. I just want you to know the 5 different problems that can go wrong with the body. So paint, solvents, glues, and varnish can affect the respiratory system, reproductive system, your memory. It can start you experiencing asthma as well as hearing loss. Okay, so these heavy metals really are a lot of, like, it's a big pain, and you can see in the diagram on the top right hand side over there, it has a solvent spillage, and as that goes, it just goes through the water table, it's moved through the groundwater, and it's just absorbed by absolutely everything. There was a lot of work done a couple of years ago where they were using plants to try and absorb a lot of these heavy metals that were in the ground, but unfortunately we can't grow plants fast enough to actually try and take the heavy metals out quick enough. All right, let's look at oil spills, and I know a lot of you are probably going to cry when you start reading this. They are from the shipping industry, can affect many birds. Important, clogs their feathers. And then important, it affects their waterproofing of the feathers, which as a result, these birds are unable to control their body temperatures. Okay, so if I can't move my wings, it's like you not being able to move your arms and or your legs. You wouldn't be able to, move your feathers to actually get some cold air underneath, and that leads to these birds dying. They're also probably eating or ingesting a lot of this oil as well, which is going to severely affect their internal digestion. But besides plants, one of maybe the more important ones, and I'm not saying birds are not important, I'm just saying this is more important because we've spoken about this already. Oil also kills phytoplankton and other marine organisms, and so marine food chains are severely affected by oil spills. So there's 2 things that phytoplankton do. The first thing is it acts as a carbon sink. It's able to take all the carbon dioxide out of the atmosphere and actually go through the process of photosynthesis, acting as a huge carbon sink. The second thing is that this plant-like structure actually acts as food for a lot of individuals. Now, if you are an animal that eats lots of phytoplankton, all of a sudden it disappears, you are going to die. It's the equivalent of taking all the grass away from any animal that lives in the Kruger National Park. If you take all their grass away, they will have nothing to survive on, nothing to create energy from, and eventually they will die. And if they die, the carnivores will die. If they die, the scavengers will die, and so on and so forth. All right. So common salts found in water pollutants, I'm really not interested in this, so don't write this down. It's sulfates, sodium, and chlorides. To a large extent, we use those as disinfectants in our water, or it's just something that is often thrown because of food or industry. So high salt levels can be toxic to humans, plants, and animals. And then this is important. Irrigating with salty water causes salt to build up in the soil and make it unsuitable for plant growth. So if you could imagine a piece of rock salt, now throw all that rock salt into the soil and pour some water over it. Initially, the salt is going to dissolve, but then eventually when that water evaporates, the salt is going to grab onto the soil particles next to it. Now, that entire block of sand that you've just thrown the salt over cannot be broken into, not even by plants. Plants can break down rocks, but they can't break down very salty sand, okay? And if that happens, you'll see entire areas which will just have no growth whatsoever. And if you're a geography student, you'll understand at the bottom of a katina, which is the bottom of a mountain, you will actually find a lot of these salt places as well. All right, let's look at agricultural use. So we all know it's used for drinking and irrigation. Woohoo! This is important. Water used for agriculture may contain the following pollutants, such as pesticides, herbicides, and fertilizers. Okay, so pesticides kill insects, herbicides kill plants, and fertilizer makes plants grow better. All right, so it's strange that both the ones that kill plants and make plants grow better are in the same sentence, but I'll show you why now. So first of all, whilst pesticides and herbicides kill organisms that eat and compete with their crops, they have been found to be harmful to humans. So we think a lot of the time we're just affecting the insects and other plants around there, but what we're really doing is affecting how we are being affected, okay? They have been found to alter fat metabolism, affect nerve transmission, reduce resistance to infections, and finally thought to cause breast cancer, okay? And there's a lot of research on all of this stuff, and to a large extent, if you go and buy your organic plants and vegetables, you'll be able to realize that a lot of people tell you to wash them before you actually. Oh wow, there's a very loud noise. This day's not going well, grade 11s. Someone's cutting down a tree now. Oh, anyway. If you go and buy organic stuff, even then they tell you to wash your fruits and vegetables because there are potentially pesticides on the outside of it. Almost finally, fertilizers and sewage can be easily washed into river streams and lakes. The nutrients, phosphates and nitrates, and potassium in these substances called eutrophication. Remember that from grade 10. So eutrophication, I just need you to know the definition for grade 11. I don't expect you to know how it works. So eutrophication is the accumulation of nutrients in water, which causes excessive algal growth. This leads to a reduction in oxygen levels and the death of aquatic life. Finally, all that you need to pick up from this is that different water requires different amounts of salts, so on and so forth. So for instance, the water that we use for irrigation doesn't need to be at the same standard as the water we use that we drink out of our taps. One of the most dangerous salts that can be found in water that is often in the water that we drink is called fluoride, and fluoride is used in toothpaste so that your teeth don't rot and damage at a very young age. But what we've found is that certain toothpaste, you'll see if you read on your toothpaste, some of them will say don't brush more than twice a day. And that's because an increase in fluoride can actually cause mental and psychological diseases, and can cause you to go completely crazy because it affects how your nerves function. So just know that there are different kinds of water for different kinds of areas and different kinds of purposes. All right, grade 11s, look after yourself. Cheers.